Hey everyone, Brother Burger, welcome to the next data demonstration where we're going to be talking about linear regression and dummy variables. This is a fun one. Um, Up to this point, you've been somewhat limited in your analyses to only two variables. Now you get to use more than two. Linear regression is a great introduction to regression and to kind of understand how it works and all that good stuff. So hopefully you've already done the readings, so you have a good-ish sense, right, of kind of how regression works. You have the regression equation and all that kind of stuff. Now, I just wanted to reemphasize that with linear regression, your independent and dependent variables must both be interval ratio. That means that there has to be the possibility of a true zero. So let's work with an interval ratio dependent variable. Again, following the theme of fertility and talking about childbearing and all that good stuff, we are going to be looking at a variable in the 2022 GSS called chilled idle. And this is the respondent's opinion on the ideal number of children. So go ahead, run a frequency on it. So chilled idle, this is with weights off, and this is what we see. We're just kind of giving it a look, right? That's always the first step before doing your analyses. Run frequencies on your variables just to get a feel for what's going on. So looking here, what do we see? We got 0 through 7. They top coded 7. So if they said 10 or whatever, their code is 7. But then we have this other category, as many as you want. And look at that, there's 645. I mean, that's a good quarter of the sample that responded that. We better go look at that variable. So let's go find chilled idle. Chilled idle. Sounds cool, right? Okay. And let's look at our value labels. Ooh, 8. Let's code it as many as you want. Do we need to do something with that? What do you think? If we don't, what's the problem? Well, as many as you want does not mean they said 8, right? In fact, as many as you want means they didn't give a number. So we don't want to include them in our analysis because we don't know what number they actually said. So that is definitely something we'd want to bring up in our methodology as we're talking about our analysis. We'd want to say, hey, a quarter of the sample said as whatever they wanted, that whatever you want is how many you should have. They didn't have a strong opinion to it. But let's go ahead and make that missing. So discrete values make 8 missing. Let's check out now the next variable that we're going to be using. So we're predicting the ideal number of children. What might predict that? Let's explore the number of siblings they had. So click go to sib or search and look for the variable sibs. So here we have sibs. Oh, good. It's numeric, right? We don't have to worry about that. You know that because you did the reading. Um, there were some interesting outliers, right? When we run a frequency on sibs, we have some people who reported a high number of siblings, like really high, right? Up into the 30s. Let's make some cases missing here, right? Because while these cases are important, the fact that it's like 36 and our average is 3.41, it's really pulling our average, right? It's pulling it to the right. This is kind of that same issue. We got to kind of protect the majority of the data a little bit from those outliers. But I don't want to take out too many. So let's make cases 16 and higher, like we did in the reading, missing. So what did it range to? 36. So we'll come here to missing values. The low would be 16 and the high would be 36. And just for funsies, what's the data look like now? Okay, it didn't change much, right? The mean didn't. See, it's a 3.41 and here's a 3.3. But what did change is a little bit more of that standard deviation, right? It dropped a little bit. It's still pretty high. These honestly are probably more outlierish than we realize, Like I don't want to cut anymore. Feel bad cutting these 37 people. All right. Let's now run our regression. So we'll go to Analyze, Regression, Linear. We have a place for independent and dependent variable. So our independent variable here is SIBS, and our dependent variable is that chilled idle. Okay, before you click OK, make sure to click on Statistics and click on Confidence Interval. And I'm going to look at it, and I'm going to turn on my weights, run it again. Now, if you are running your regression, you get something weird where it's after the weights and you try to run it, it's like there's no data. Make sure you're using the right GSS. You should be using the one where the weight variable is a copy of the WTS SNRPS underscore AS variable. So make sure it's that one, just in case you're in a problem. I had the wrong data set up. I was getting all frustrated. I'm like, why is it not running with weighted? Anyway, let's rerun that regression. All righty. So we have our unweighted and our weighted information here. So unweighted, we need that so we can get our unweighted sample size. It's the dumbest thing. You look at the ANOVA table, degrees of freedom, total +1. So we have 2,035. That would be our total sample size. Now let's come down here and let's see what we get. So as I'm looking at regression output, it's bad. Now I just kind of look all over the place. But as you're beginning, I would encourage you to use that guide in the handout. So first off, we looked at our sample size. Now let's look at our significance. Okay, yes, the slope is statistically significant, so that's good. We can have confidence that like it's actually doing something in the population. Now let's actually look at the slope. What is the magnitude and direction? 0.08. So the slope, right, is the predicted change in y given a 1 unit increase in x. So for each increase in the number of siblings, the predicted ideal number of children goes up by 0.08. Yeah, okay. I think we'll play around with that in just a sec here. We also can look at the 95% confidence interval of the slope, and we can see it's pretty tight. That's good. So we can have confidence in that slope. We're pretty sure that's probably the range in which it's happening in the population. And then we look at the beta. Okay, so betas are the standardized coefficients, and they can be interpreted on a scale of like 0 to 1, right? Where 1 means it's like super strong. So this tells us strength, the strength of the association. And this beta is pretty good. I mean, 0.22, it's better than less than that. So it seems like number of siblings is kind of having an impact. But there's still so much more that predicts whether or how many people feel is the ideal number of children. Because when we look now at the R squared, the goodness of fit, this tells us the proportion of the variance in Y explained by our model. And we see our model is only explaining 5%, 5% of what explains opinions on the ideal number of children. How it's figuring that out, by the way, is it's looking at the slope. So if you can imagine a slope that is like really flat, right? Kind of like this. It's not explaining a whole lot, right? If you had an R square of 1, that would mean that you had a perfect correlation, that for 1 unit increase in X, you have a 1 unit increase in Y. And we're far from that. That's not what we have. Alrighty. Let's add some more stuff though. Let's see if we can't figure out what predicts people's opinions on the ideal number of children. So let's play around with a little bit of SES stuff. So let's come back to our regression and let's include the variable educ. So this is the number of years of education that they have. Now from the reading, you know that this plays a pretty important role in predicting the age at which they had their first kids. Is it going to play a role in the age or then the number of ideal kids they think people should have? We'll see. So with educ in there now, this is what we see. Okay, so the significance, is it significant? Yes, right? I mean, it needs to be less than 0.05. Don't get into the whole like it's very significant or anything like that. It's either statistically significant or not, or it's not. Now it's true, right? That as this gets closer to 0.05, the effect size are going to be smaller, but focus on that. Don't be like, oh, it's approaching 0.05, it's weak. Don't do that. Okay, so we look over here. Here's the coefficient, the slope. So for each year's school someone gets, the ideal number of children decreases 0.02. Okay. Beta wise, ooh, it's only a 0.05. Education doesn't seem to be a very powerful, like heavy hitter here in helping us understand the ideal number of children. And in fact, when we look at the R squared, we can tell it only improved our model by 1%. Not a whole lot. Okay, so what might be? What might predict or help us understand the ideal number of children? Well, maybe we need to move beyond a bunch of interval ratio variables, right? I mean, we can keep on trying to add in things like, well, let's do one more, and then we'll start talking about dummies. Let's do add in, actually, no, let's go on to talk about dummies. Let's talk about dummies. Okay, so we could keep on trying to add in a bunch of interval ratio variables, but there's only so many. And frankly, some of the coolest stuff that we like to study in sociology is not interval ratio, like race or social class or religion or any of those kinds of things. They're not interval ratio variables. So I thought maybe for this next part, it would be interesting to include this variable here. Speaking of religion. So this is not religion. Hold on. It's called rel person. RELPERSN. And so this question asks how religious they feel they are. So they could have responded very religious, slight religious, not at all religious, moderately religious. Or sorry, very religious, moderately religious, slightly not religious at all. Okay. So we want to include this variable that is an interval ratio. First off, it's tough to be like, oh yeah, the differences between very and somewhat is quantifiable or very moderate. We don't know exactly how much distance there is in that. And secondly, interval ratio data has to have the possibility of a true zero. Do we see a true zero here? Well, watch this. Just because we're lazy, let's just throw it in, right? Let's find real person because it's like, well, but it goes in order, right? It goes from very religious, not religious. Let's just throw it in. It's kind of like a scale variable. Let's throw real person in. And click OK. Let's see what we get. Ooh, look at our R squared. It went up 0.11. Hey, we like double our R squared with one variable. Sweet. Is it significant? Yes. The slope, negative 0.22. So what does that tell us? As we not religious goes up, right? Because it starts at 1, ends at 4. Number ideal children goes down. But here's the weird thing. Remember the constant. This is the value of y when all the x's are 0. With the interval ratio data, that makes sense, right? Number of brothers and sisters, can you have 0 siblings? Yeah. Can you have 0 years of school? Yeah. Can you have 0 consider yourself a religious person? There is no 0. I mean, it starts at 1 with very religious and ends at 4, not religious at all. But the equation doesn't know that. So it created an artificial 0. We don't know what it is. And that's what's represented by the constant. So we cannot just enter in ordinal and nominal data. We have to do something special. We have to create dummy variables. Okay, now let's just remember here kind of what these four groups are. And in fact, I'm going to write it down so I don't forget as I go to the whiteboard. And maybe you should too. Okay, so for real person, we got 1, 2, 3, 4. Very religious is 1. Moderately religious is 2. Slightly religious is 3. And not at all is 4. All right. So we got to find a way here, turn this religious variable in a way that we can include a valid 0. Let me open up a quick whiteboard, okay? Because remember, with that regression equation, it is y equals a plus bx, right? And we need to know all the information in this equation to be able to solve for y, for it to be able to work. So we need to know this, the constant. This is the y-intercept. Oh, such a crooked line. This is the value of y when x is 0, right? Where the line crosses. So we need to be able to know that. But with the real person, we don't have that. We don't know. Well, let's create a bunch of dummies here real quick. So dummy variables are always, always, always coded 0, 1s, always. And the 1 represents the thing we're interested in. 0 is everything else. Why do they call them dummy variables? I'm not exactly sure. I think it has something to do with old school 50s electronics, like dummy loads. You can also think of it as like a dumbed down variable, right? Because we have real person. I think I misspelled that. Anyway, where we got our 4 categories, right? So very religious, moderately, slightly, and not at all. Well, we're going to dumb it down. There's only 2 options for each category. So in making dummy variables with any given variable, a few things to do first. Make sure it's squeaky clean, right? We want to make sure it's a nice, good, clean variable. That there's no weird missing values or anything like that that we need to contend with. We're okay here with rel person. So we need to create 4 variables. So it would look a little bit like this. We need to create a very religious dummy. We need to create a moderate religious dummy, a slight religious dummy, and a not all, and that's what I'm going to call it, underscore D, or religious dummy. I like to, with variable names with dummy, sometimes put an underscore D, because then that tells me it's a dummy. Now, each dummy needs to be coded 0, 1, right? So each one of these has a 1 and a 0. Should give myself a little more space. 1 is the thing that it represents. Think of it as like the on switch, right? So the 1 here with very religious, that's our very religious people. 0, everybody else. So that's our moderate, our slightly, and not at all people. Okay, then it's the same for the others. So 1 is moderate. I'm going to do this kind of quick. 2, this one would be slight, and this is not at all. Right, and here, the 0, this is going to be your very religious, slight, and not at all. Down here, where 1 is slightly, right, 0 is going to be all the other groups. So we have very, moderate, and not at all. And in the not at all group, it's everyone else but them, right? So we have very, moderate, slightly. Okay. So we have, let's see if I can clean this up a little, make it a little easier. We have 4 dummy variables now, where 1 represents the group that we're interested in, that's named after the dummy, and 0 is everyone else. So here is where it gets fun. So with the linear regression equation in mind, and remembering the need that we have to have a constant, we have to have a y-intercept when it's equal to 0, how can we make this work? If we were to include all 4 of these categories, is there one group that could be represented by a 0? No, right? Because they all have ones. So very religious has 1, moderate religious has 1, slightly religious has 1, not at all religious has 1. But let's say we made not at all religious our reference. So what we would do is we would not include this dummy in the regression, in PSPP when we're running it. And this is what would happen. Now, who's the only group that can be represented by a 0? Can moderate religious be represented by a 0? No, they have a 1 over here. Okay, so it can't be them. Can slightly religious be represented by a 0? Nope, they have a 1 over here. Okay, well, with moderate, this one here, with the mod rel D, can very religious be represented by 0? Nope, they got a 1 up here. Can slight religious be represented by 0? Mm-mm. Have you seen a pattern? And with slight, right, the very and the mod can't be the 0. So by not including the not at all, it's like we're telling PSPP, forcing it to make not at all religious the 0. And that allows us to run the regression because now we have a true 0. But how we interpret it changes, right? So whenever we interpret the slopes for these groups, it is in reference to our reference group, not at all. We always got to remember that. Whenever we see these slope coefficients for very moderate or slightly, it's the predicted change that they produce in Y compared to not at all religious. So let's do this in practice, okay? Let's make some quick dummies. So let me get out of this screen share here. Go back to sharing PSPP, and let's do this. So the easiest way to do this is definitely syntax. Don't try to use transform and recode it into another variable. It will take you forever. All right, so we got 4 dummies here to make. So first off, let's make our very rel D. So compute very rel D equals very rel D. Execute. And I might post this syntax for you because you can get plenty of practice. Why don't you watch on this, okay? Just so you can kind of see what it's like, what it feels like. Okay, so I computed very rel D. All right, now I need to put in my ifs. So if rel person equals 1, which means they're very religious, very rel D equals 1. That's the on switch, right? That's where it's on. Now I need all the other categories. I'm going to be lazy. I'm going to copy and paste those suckers down. So let's make sure as you copy and pasting's good, but it also introduces the possibility for human error big time by missing something, right? So make sure you get it right. Okay. So let's look at what we got. So if rel person equals 1, that means very religious, very rel D equals 1. And then all the other categories are being coded as 0. I'm dumbing it down. I think that's why they call it dummy variables. Like, serious, I think that's like a new epiphany for me this semester. Oh, fascinating. All right, let's do the others. I'm going to copy and paste. One day, PSPP will introduce a find and replace feature, which will be super nice. If you have SPSS, yeah, you can do that. All right, so let's change these. So instead of very rel on this one, this is my moderate. I'll show you another trick here just to save you a little bit of time. Yeah, I'm going to show you 2 tricks. But first, let's do it the old school way. The first couple times you're making dummies, I would kind of prefer you to use this approach where each line is kind of each group. one of the advantages to doing this, especially as you're beginning to learn how to do this, is you can very clearly see, right, like where each group is binned or where they belong. So rel person two now is the one for mod rel, so moderately religious. Let's do the slightly religious now, and I'm going to cheat just a little bit. I'm going to use Word. I'm going to copy the old syntax here and paste this. Now I can use a Control F, find replace, and instead of vary, because I want to replace it to slightly, I'm going to say take vary and replace it with slightly, and then replace all. And there it changed it all. Isn't that nice? Now, the only thing I need to change is where that one goes, right? Because I want to make sure rel person three, which is slightly, is the one on my slightly rel dummy. Then I can copy and paste it. That's nice. Now, here's another trick you can use. We'll do this with the not at all. So compute not rel d equals not rel d, period, and then execute. So you can use the not equal sign. So if rel person equals 4, because that's the not religious, not rel underscore d equals 1. Then I can say if rel person does not equal, it's that funny little squiggly that's next to the 1 on your keyboard. If rel person does not equal 4, right, that means it has all the other variables. Not rel d equals 0. Now, something to be aware of. But we do need to check this now. Let's look here. Okay, we're okay. But if, for example, here with rel person, there was like a negative 99, like a refused or whatever, we wouldn't want to use that not equal to 4. Because even if this was labeled as missing in the missing value column, it would still suck it in. And then that's going to screw up our dummy variable because now we have a bunch of missing data as the 0 or whatever. But we're okay here. No issue. All right. Let's run these dummies. How many errors do you think we're going to get? My goodness, I have a lot of windows open. Okay. Hey, no errors. Sweet. Now, the first thing to do after that, making sure there's no errors, run frequencies. I'm going to turn my weights off just so it's not all crazy. Run frequencies on your dummies and the original variable. Always do this. It is just such good practice. This will save you so much heartache. Because I have seen so many students struggle with their analysis because they had messed up on one dummy, right? Like if you mess up on one dummy and try to put it into your regression model, it'll crash the whole thing because you have to have complete case information across them all. So a very common mistake I see is students will fail to get a 0 in somehow with the dummy, and that will really mess it up. So we have here our original variable. So 555 very religious people, and that's what we see here on the 1. Okay, for mod rel, it was 1321, and that's what we see here. Slightly rel, 997, that's what we see. And not rel, sweet, we get it. Now we can run our regression. So let's go analyze regression linear. And let's put in our variables. Now, we got to choose one to exclude, right? And that becomes the reference group. Which one do we exclude? Do we do like the one in the middle? Because then we can see like the extremes, or do we do the top or the bottom? I would recommend not randomly pulling one from the middle like especially when it's kind of ordinal like this, makes it really hard to interpret. It's nice when the reference group is on either end, the high or low, because then you can be like, as it goes up, this is what happens, or as it goes down, this is what happens. Now, we're the question, the way it's asked, right, is like, what is predicting the ideal number of children? Um, and since we're interested in religion, let's leave not rel as the reference. So let's put in very rel, mod rel, and slightly rel. We're not going to put in not rel. That doesn't mean they're not in the regression. They're just hidden, or not hidden, but they're the zero, right? They turn into the constant. Let's click OK. Now, before looking at it, let's turn on our weights. Let's run it again, just so we have that done. Okay. It a little. Let's see what we get. Now, we have here, let's kind of go through the list, right? The process. Let's look at first at significance. Ooh, what changed? Look here, highest year of education, no longer statistically significant. Now it is at the 0.059. For Pete's sake, that's pretty close, right? I mean, p-values are totally social constructs. If I was writing about this in a paper, I would still mention education, but say something like failing to meet traditional criteria of significance or something dumb like that. But I would still talk about it. It seems like education is doing something, but it's weak, right? I mean, look at the beta. It's only a 0.04. It's a lightweight compared to these other variables that we included in the analysis. And you can see that with the slope. I mean, for each year, it goes down by 0.01. So what? 20 years of education is going to reduce the ideal number of children by 0.2. Like, that's not much. But let's look at the others. Okay, so that siblings one still playing a role, huh? So the number of siblings you have increases the ideal number of children by 0.07. Not by much, but it does something. Religion does something, huh? So if you said very religious compared to the not religious at all, because they are the zero, right? When we look at the constant, constants get weird when we start including multiple variables. Don't get too hung up on it. But this would be like this 2.21. This is the predicted value of y when number of brothers and sisters is zero, education is zero, and not religious, because they're the zero now. So we can see though, the cool thing though about the way we have it set up, where not religious is the reference, we can see that as religion goes up, so too does the predicted number of ideal number of children. So it seems like it is doing something, religion is. Very cool. Now, even with this cool model, we're only explaining 11% of the variance. That means 89% of what explains the average number of children, or the ideal number of children, is unexplained for in our model. So does that mean we throw in the towel? No. This means we keep looking. All right, y'all. That was fun. We're going to get a lot more practice in with dummies on how to interpret them and do all that good stuff. And we have lots of time ahead of us to practice with regression. The nice thing is, the work that you're putting in now with regression, I mean, it's kind of new. There's a little bit of a learning curve. The nice thing is a ton of this logic applies with logistic regression, the next one we're going to learn. It's not going to be like relearning a brand new tool. All right. Well, you have a fantastic day. I'm tired. I'm going home. And I will see y'all later.